In this presentation, I'll be explaining solar thermal system, that is an introduction to that solar thermal system, in which how the solar radiation is converted into thermal energy. That will be explained in this presentation. Now coming to solar thermal system, solar thermal energy, the short form is STE, is a form of energy and a technology for harnessing solar energy to generate thermal energy or electrical energy for the use in industry, in the residential and commercial sectors. And the thermal energy collected by the solar collectors is used for producing steam, hot water, etc. Now, as an example, this is a solar water heater picture, and this is the basic diagram of solar water heater, in which this is called the collector that collects the solar radiation, then convert that solar radiation into heat energy or thermal energy. That is done by this collector, flat type collector, this one. And in that one, here there is a heat transfer fluid is there, that is passed through this one. That thermal energy is transferred to the heat transfer fluid. There's a pumping mechanism is there, control to that one, and that heat transfer fluid is flowing like this one, and that heat is transferred using this setup here, or heat exchanging mechanism of this one. Here in this one, a cold water is entering to this, and because of the heated fluid here, the cold water is getting heated and we are getting a hot water at the output of this one. Similarly, this can be gone to a boiler, so that we'll be getting steam of this, used by the boiler. That can be get it that one. Therefore, this is one method of converting a solar radiation into the thermal energy. So this is a pictorial representation. And another one is the solar energy converted into thermal energy is fed to steam thermal or gas thermal power plant that can be used to generate electrical energy. Or that is the just block diagram is represented here. Therefore, this is the collector. There's a parabolic type of collector that can collect both direct radiation or beam radiation and diffuse radiation. That can collect that one, that gets heated, and this is the water is flowing through that one, that is getting heated, and there's a water storage, that one, so that the water is getting heated in this one, and here that water is passing through a heat exchanger. In that one, what vapor is being generated, and that highly temperature vapor that will be heating this one. This is a heat exchanger asset. Here the working fluid is passed through a pump. It is being transferred. The heat is exchanged to the this working fluid, and that is passing through a turbine. Turbine gets rotated because of the thermal energy or heat energy, and finally that after that one, that gets condensed, and that is repeating that one. Therefore, here the thermal energy of the solar radiation that is used to produce the electrical energy, or this turbine is to the turbine will be connecting the generator, and can generate electrical energy. Therefore, this is a basic block diagram of how the solar energy can be converted, and that can be fed to a steam thermal or gas thermal power plant. That is the block diagram as it. So this is a solar thermal system. Now coming to the principle of conversion of solar radiation into heat. When the electromagnetic waves coming from the sun hit an object, they excite the molecules of that object, causing them to move. And this molecular movement is the heat. And heat is always moving from higher temperature to lower temperature until the temperatures are equal. And this is what we know as heat transfer. The process we call it as heat transfer. Now coming to this one, the incoming solar radiation or sunlight is falling on this one, that is coming to the surface of the earth, and here that is falling, and certain portion is the light is absorbed by the carbon dioxide, and a part of is back radiated to the ground, that because that one, and here the isotropic heat emission into the space, that is infrared radiation after heating this one, that is reflecting that one, that is infrared radiation is that. Therefore, this is the earth surface as such. For the heat conversion by greenhouse effect, that's called the heat greenhouse effect. The greenhouse effect is the process through which the heat is trapped near the earth's surface by substances known as greenhouse gases. Greenhouse gases that is called carbon dioxide, methane, nitrous oxide, and water vapor. Because of all this one, the heat is being trapped near to the Earth's surface, and that effect we call it as greenhouse effect. Continuing the principle of conversion of solar radiation into heat here, energy from the sun comes in the form of light as a short wave radiation. The wavelength is small and short wave radiation that is hitting that one. When this radiation strikes solid or a liquid, it is absorbed and transformed into heat, and the material becomes warm and stores the heat and conducts it into a surrounding material, that's water, air, and other solids or liquid, or re-radiates into other materials of lower temperature. That is, this is radiating into other materials of lower temperature, and this radiation is of long wave radiation. This radiation is of long wavelength is more, and this short wavelength radiation. Continuing the principle of conversion of solar radiation into the heat here, the principle of converting solar energy into heat is known as greenhouse effect. And when the sunlight reaches the Earth's surface, that is, it's not Earth's surface here, some of the energy is absorbed and converted into heat. This heat is then re-radiated as infrared radiation. This is re-radiated as infrared radiation. Certain gas in the atmosphere, such as carbon dioxide, methane, and water vapor, act as a blanket and trap this infrared radiation, preventing it from escaping back to the space. And this trapping of heat energy leads to an increasing in the overall temperature of the Earth's surface and lower Earth's surface and the lower atmosphere. Here the temperature increases because of the trapping of this radiation, and because these one, the carbon dioxide, methane, and water vapor act as a blanket and trap this infrared radiation, so that the temperature here gets increased. Now, this absorption and retention of the heat from the sun is the fundamental principle of behind the solar thermal energy conversion system, which uses the greenhouse effect to collect and stores the solar energy as heat. And these systems, such as solar water heaters and solar air heaters, utilizes various materials and design to effectively capture and transfer the solar heat energy for practical application. We'll see in the later what are the application of the solar thermal system. We'll see later. And okay, this is just show that one. This is a solar water heater, and there are different types of application. Now the glass easily transmits short wave radiation. That is short wave radiation, that glass it can pass easily, which means that it poses little interference to the incoming solar energy, but it is a very poor transmitter of long wave radiation. Once the sun's energy has passed through a glass window and has been absorbed by some materials inside, the heat will not be re-radiated back outside if it is a glass as such. It cannot be re-radiating the short wave if the glass one. Therefore, the glass acts as a heat trap. Therefore, the glass is acting as a heat trap because through the glass, the short wavelength radiation will be passing. But after that one radiating, that once the solar energy has passed through the glass windows and glass window and has been absorbed by some materials, the heat will not be re-radiated back outside, so that the temperature increases and glass is acting as a heat trap. Now we'll see just what is a solar thermal collectors. In the next presentation, I will be explaining what are the different types of solar collectors. Just an introduction only, that solar thermal collectors. Solar collector is a device for collecting the solar radiation and transfer the energy into a fluid that's called heat transfer fluid, HTF, and passing through it in contact with it. Therefore, here this is the collector, flat type of collector. Solar radiation is falling on this one, that convert into thermal energy. Therefore, this is a fluid that through that one the heat energy is being transferred, and that is being transmitted to that one, as I already explained. Here heated fluid is flowing, and here cold water is entering, and that cold water is getting heated because of this heat, say transparent one, and that heated water is going outside that one. Another one is going to a boiler also. Therefore, here this is a one type of collector. This is called the flat type collector, and we'll see later what are the different types of collectors used. And the mainly two type of solar collectors. One we call it as non-concentrating or flat type collectors. Another one we call it as concentrating or focusing type of collectors. Will be see later. For non-concentrating type flat collectors, flat type collectors, this is a flat type collectors, and non-concentrating and concentrating type, that is a focusing type of collectors. Now, why we are going for a solar thermal energy? The advantages are it has got a high energy conversion efficiency. For the solar thermal conversion efficiency is around 70% to 90%. But if you see a solar photovoltaic system, the conversion ratio is less than 20%, between 10 to 20% only the solar photovoltaic conversion efficiency. But here efficiency is much higher. That's the first advantage of solar thermal system as such. Another one is that since because of this efficiency of this one, the solar thermal has got the payback period 3 to 6 years is the payback period. But if it's a solar photovoltaic, it's much higher. 5 to 15 years are taking for to get the the invested amount. That's so shorter payback period for the solar photovoltaic. But this is better. So less. Here more years are taking, not shorter. Shorter is for the solar thermal system and compared to solar photovoltaic system. And another advantage of solar thermal is that reduces need for other heating systems. That is saves the energy and the money. Therefore, these are the advantages of solar thermal system that's widely using. And we'll be seeing in the next presentation what are the different types of collectors used for collecting or converting the solar radiation into the thermal energy.